What's going on YouTube? My name is Joel Rivera, and it's time to learn something new. Hey, first and foremost, I would like to excuse myself for taking a little 2 or 3 week hiatus. I'm back on the grind, just basically life gets in the middle, work, family, everything. But we're back here and we're here to continue doing the work. I know last time I had said that quite possibly that I was done with the lab that we were working on, but I figured there's a couple more things that we could do that I feel like are essential. And with this, I think we'll be done with this lab, and then I'll start developing some others. Probably instead of a long series, it'll be short labs specifically for that week, and not necessarily a whole series of videos. Without further ado, let's go into the topic. So I figure we need to talk about managing our Cisco devices. Now, there are different features, technologies, protocols that you can use in order to manage your Cisco devices. The ones that we're going to cover in this lab are your common ones that you will use very frequently, very often. Um, so we're going to be talking about Snp, Syslog, Ntp, and some other technologies and features, like I said, that Cisco provides. Without further ado, Let's get into the lab. If you go to my website, I already have it. I have already created this lab, and I will link it obviously down below in the description, where you can just link to my website and follow along. So you can follow along with me, or just watch this video and then try to do it yourself from watching the video. Based on your memory. Again, as I was saying, that our Cisco switches and routers, they're essential in maintaining our maintaining a healthy network. So, there are numerous protocols, features, technologies that we use throughout our networks in order to help administrate and support the network. Okay. And in this lab, like I had said, we're going to go do a couple of them, which are Ntp, Snp, Syslog, obviously ACLs, and Tftp. Now, these are not the only technologies that you will use, but they're the most common ones used. I wanted to use Linux in order to show you in action what these technologies are actually doing. Okay, so without further ado, let's start this lab. I already started up my devices. I am only going to use router 1, switch 1, and this Linux management device. So I'm going to open those up. We're going to start obviously with router 1. Let me make sure I'm not in the middle of the view. Okay, as always, we got to enable to get into privileged exec mode. Once we're in privileged exec mode, we're going to go to configure terminal. Okay, the first action or the first task that my lab will require is that we configure a banner, message of the day. A banner message of the day is used as a way to indicate what's going on the network, or it was originally used for that. So you would, get onto the terminal, and the administrator may have a message that indicate this service is down or this service is being worked on, so on and so forth. But now we use banner message of the day as a way to indicate if someone's trying to log into our system, as a deterrent, to stay away, and if you're not authorized to enter our network. Whether people who are malicious are going to follow that, it's probably not, but we still need to do it. And quite possibly where you work, the policy dictates that you do have a banner message of the day. So you would just enter whatever the policy dictates. I'm just going to do a quick message, and I'm just going to really reuse what's here. Well, I actually have it over here, so I can just copy this. Okay, so on router 1, we're just going to create that message. Again, for banner message of the day, whatever symbol you use, so I use the hash symbol, that will be the symbol that will be needed in order to complete the message. So obviously you wouldn't use a symbol like the period as your you know your character to terminate, because you might need to use periods. You want to use a character that is not going to be in the message. For the most part, I've seen in the industry mostly just using the hash symbol. I mean, the pound sign. Sorry, the pound sign in order to terminate the message. So, as I said, I just copied that information, but you can write your own information. Most of the time, it's just this device is for such and such purposes. If you're unauthorized, please stay away. It'll go into that. Probably in your policies, they'll dictate, they will have a specific message that you will place there. But for our last purposes, it's just something simple. All right, enough with that. Let's move on to the next task. Okay, so we're going to create an ACL to protect access to router 1 using a standard ACL. Permit only the Linux management server, which is 192.168.10.129, to access via SSH on router R1. Make sure to log all denied traffic and successful entries. Okay, so we're going to need to create an ACL, and we're going to need to do it on, obviously, if it's via SSH, we need to do it on our line VTY lines. So as we access line VTY, we should make sure it is only going to allow SSH traffic, and that we only allow that server IP. So what we should do is, as it says, create a simple ACL. Now, I don't remember specifically. Let me just do show access list. I want to see what access lists I currently have. Make sure I don't reuse any. I guess we can use access list standard 5. Let's go with that. So IP access list standard 5, and we need to permit what is it? Permit 192.168.10.129, and we want to make sure we log those entries, and also we want to log any unsuccessful entries. So with the implicit deny at the end of the access list, we if we didn't need to log, we could just leave it as that, and only that IP would be allowed and everything else would be denied. But since we want to make sure we log it, we need to do deny any log. Okay, so deny any log, and that's going to make sure that anyone who is not 192.168.10.129 that tries to go into the network, our router is going to log them that entry. So we'll be able to see in the future if someone is trying to find a way into our network that shouldn't be a user who shouldn't be trying to access, then we'll see that message, and that could be used later on to either whatever policy dictates, fire that person if it's deemed as that person is trying to purposely maliciously get into our network, or maybe it's just a mistake. But anyways, if they try to and they're not allowed to, they're going to be logged on the syslog of the router. Okay, moving on. So we completed that task of creating the ACL, but now we need to make sure we place it on our line VTY line. So we're going to do line VTY 0 through 4. first thing I want to do is indicate the access list that we're going to use. So access class 5 in. So it will log it in its entry when it's trying to come into the network. And we want to do transport input SSH and also login local, so that we make sure that locally they're logging in. Okay. Again, as you can see, if you follow my website, I always leave a message explaining what the task is, but not necessarily, giving you. I always leave. Okay, as I was going to say, I always leave an explanation, a short explanation of the task that you'll need to do, giving you hints, and then try to not show you what is needed to do by using this drop down that says show. Then once you hit show, you'll be able to see the the input that I used in order to complete that task. And you'll see very similar. The only difference I see here is that I made a remark on that access list. But as you'll see, that access class 5 in and transport input SSH. I did add login local, which I didn't add there. But other than that, it's basically the same thing. All right, configure NTP. So NTP is Network Time Protocol, and it's essential that our devices, our Cisco devices, and all our devices on our network actually are on the right time. Since router R1 does have access to the internet, let's add the Google NTP public server IP. And it says here, set router R1 to use Google's public NTP server. Verify that the router can ping the server, which is time1.google.com, and set the time zone to appropriate time zone. If you haven't configured your router to use DNS, you will need to do that before doing that. But we can make sure that DNS is working by doing ping. Well, since I'm in the configuration mode, I need to do ping time1.google.com, which that is the URL that we want to get our timing from. And router 1 can get the time from there. So now that they can, let's set in the NTP server. So Ntp Server time1.google.com. And what else does the task ask? Set the time zone. Okay, so time zone, I believe it is clock, time zone, and then your appropriate time zone. So I'm in the Eastern time zone of the United States, but we're in daylight savings time because it's in the summer, so it would be EDT -4. All right. As you see, there's a Syslog message that says system clock has been updated to Tuesday, June 22nd, 2021, which is when I'm doing this video. And I can guarantee that that is the appropriate time. It is 9:35 in the evening where I live. Okay. One thing I wanted to show you with NTP. So it may take a little bit to appear synchronized. As you'll see here, his clock is unsynchronized currently, but if we were to do show Ntp Associations, it's another show command, you can see that it is configured. This symbol right here, the tilde indicates that it is configured, and the reference clock ID is Google, and it appears we're on Stratum 2, which stratum refers to, so stratum 0 is the actual time, and then if you are from a server next to it, which Google obviously has a server that is stratum 1, then the next server that is getting the time, which is our router, would be considered stratum 2. And if we were to create another device that is seeking the time from our router, then that device will be stratum 3, which we will do later on in the video when I use switch 1. All right, moving on. So we completed NTP. Let me just verify maybe it has synchronized up to this point. It's not, no biggie. You know, it may take a few minutes. It sometimes does take a few minutes when you do the after you do the Ntp server configuration. But I'll show you in a little bit after time has passed that it has synchronized, and that's what you want to see. You want to see clock is synchronized, and we'll get that information in a little bit. Okay, moving on. Verify NTP, we already did that with the show NTP status. And as I had listed here, it says, note, clock synchronization may take a few minutes to appear as synchronized. Okay, and that's important. All right, configure Snp v3 on router R1. So Snp is, I believe, Simple Network Management Protocol. Let me look that up real quick. Snp, yes, Simple Network Management Protocol. And Simple Network, Snp was created as a way to manage our devices on the network. It was created years and years ago. For the most part, Snp v1 is completely clear, is clear text, and it doesn't authenticate anything. Then we moved on to using Snp v2c, which is the more common one used up to a few years ago, where Snp v3 became more the prominent one to use. Now, Snp v2c created the use of community strings to authenticate, but it was still clear text. So if anyone malicious was able to get to, tap into the network, they would be able to see they'll be able to see the community string and use that to then manage your devices. If you didn't appropriately use ACLs to block it, you could have had someone that easily could have gotten into the network and using Snp. As you'll go throughout your career, you know that Snp allows you the capability of doing a lot of things. It allows you the capability to poll, to get different statuses of the network. It also allows you to even make changes on your network devices if you properly set it up. So it can be very troublesome if you leave it in a way that you either using a weak community string or what have you, leaving it as an SMPv2. You could easily be hacked if someone is maliciously tapping into the network, getting the packets that are going across the network. So SNPv3 was created, and that added the use of authentication and encryption as well. So you can authenticate and also use encrypted keys in order to make the connection private. Okay, so that's what we're going to use, and that is the standard that is expected nowadays in our networks. So the task says create an Snp v3 group named network admin. Okay, set the group to use auth priv security level. All right, create an Snp v3 user Snp admin and assign the newly created network admin group. Set the authentication protocol to SHA and the privacy encryption algorithm to AES128. Verify that the user was properly created using show SNMP user. Okay, so there's a few things to do there. So the first thing we need to do is create that network admin group. So we're going to do SNMP v3, SNMP server group. This is where you put the server group's name, and then you do version. No. Yeah, you do version by typing v3, and that's it. Nope. Right. Since it's auth priv, we're going to type priv after that to create the auth priv security level for that group. Okay, now we're going to type Snp Server user. I believe we're calling it Snp admin is what I used, right? Yeah. Snp admin. Let's type it correctly. Snp admin. The group name, so it's network-admin. Yeah, version 3. And then I believe the way we do it is right. Okay, so authentication, we say we're going to use SHA. Yep, SHA. And this is where you would provide the authentication password. So password that we'll be using is the Cisco 123. Wait, did I? Yeah, no, let me do it like this. Cisco #1234. And then we're going to do the privacy encryption is going to be AES 128. And then we're going to use a different password. So I'm going to use that 1234. And I believe that's it. All right. Okay. And if we do show Snmp user. Okay. So the Snp admin is using SHA and AES 128 and belongs to the group network admin, and network admin uses version 3 for this protocol. Okay. And this is the Snp engine ID. All right. Moving along. We're doing good. Okay, now let's move on to switch 1. All right, so on switch 1, let's enable. And let's go into global config. I type in configure terminal. And it says, okay, configure a password and add new user on switch 1. Configure and enable password, create a new user with a secret password, and using banner messages of the day, create a banner to deter unauthorized users from logging on switch 1. So first, let's do the configure and enable password. So enable secret, and the enable secret, we're going to keep it the same as the other device because it's our lab. Obviously, you wouldn't use a simple password like that, but it's in our lab. I don't want to create something too hard for me to remember. All right, enable secret Cisco. And now we want to create a username. So the username is username admin and with a secret password. What did I use last time? Oh, right. Let's do that. So strong password 123. Was it 123? 1234. All right. Good. And the next requirement is using banner messages of the day. Create a banner to deter. So banner message of the day. I'm going to use the #. And now we'll enter the text that I already have here. Just going to copy it and paste it. All right. And that should be it for the task. Oh, create a banner to deter unauthorized login. Yes. Yeah. Okay. That's it. All right. Switch 1. Assign an IP to switch 1 from the out-of-band management VLAN. Add a default route to the VLAN's gateway address. Verify the connectivity by pinging the gateway and user devices from user VLAN. Okay. So, I believe it's VLAN 30. Yeah, VLAN 30 is the management. Okay, yeah, VLAN 30 management, the 128 network. All right, and 158 is the gateway. Let's do 157 for the switch. So config what? Okay, so now on the switch, we're gonna do interface VLAN 30, and we're gonna provide an IP address. Okay, my driver is ready to be installed. Okay, IP address, and we're gonna type 192.168.10.157, and that is a 255.255.255.224 network. And let's make sure we do no shutdown on that VLAN interface. And then it requires us to create a default route, right? Assign an IP out of the band management VLAN. Oh, let me move this a little bit this way so you guys can see it. Don't want to be in the middle of the terminal. Assign an IP with out of band management VLAN. Add a default route to the VLAN's gateway address. Verify connectivity by pinging the gateway and a user device from the user's VLAN. Okay, so we're going to do IP route, because that's going to create that default route, and we're going to do 0.0.0 to make sure it's the whole, every network that is not in the routing table will use this, and we're going to make sure we use the gateway's IP for that. So 192.168.10.158 is the gateway, so any traffic from that is not on the routing table, our switch is going to send that traffic to that gateway as its way out. Now let's test connectivity. First, let's make sure we can speak to the gateway. So we're going to do ping 192.168.10.158, which is the gateway's IP. And then we're going to do a ping to a user. So 192.168.10.1. I believe is a user, and that is a success. So we're able to access out. Now, if I recall, there is a ACL on router R1, so that's not going to allow me to ping a website. So just to verify to make sure, if I do ping.8.8.8.8, which is Google's publicly known IP, as you can see, I'm using the IP address. I'm not using a URL because we don't have DNS configured on there. So VLAN 30 is blocked. So we need to make sure, if we're going to do that, which I do need to for the Linux device, add the capability to allow this VLAN to exit out. We want to do that because we need the Linux server to have access to those we need the Linux server to have access to the internet in order to download the APTs, the package manager packages for the different technologies that we're going to install, which is Snmp, Syslog, and I believe Tftp. Okay, moving on. Enough with that. Let's keep moving. Okay. Right. Okay. Configure a password and add a new user. We did that. Assign an IP to switch 1. We did that. Configure a domain name. Assign a domain mylab.local to switch 1. Okay, we already did this previously with router, and now we're going to do the same. So IP domain dash name, and we're going to call this mylab.local in order to create the domain name. All right. Yep, that's a simple command. Okay, configure, generate an RSA key, set the module bits to 2048, and make sure you use SSH version 2. Okay, so we need to configure SSH, and in order to do that, we're going to create the RSA key, which we do that by doing crypto key generate RSA. It's going to ask us how many modules bits we want to use. We're going to use 2048. It may take a few seconds, but it's pretty fast because we're on the lab environment, so it should be pretty quick. And to make me look bad, it's taking a little bit longer. Okay, 11 seconds. That's not too bad. Okay. The other requirement of this task was to use SSH version 2. As you can see, the log message is saying that we're using SSH 1.99. So in order to use SSH 2, we do IP SSH version 2, and that's going to enable SSH version 2. All right. Again, if you go to my website, you'll see the task at hand, give you a hint on what you need to do, and then if you get stuck, you can always hit the show button to show what commands I entered, or if you once you completed and want to be sure you got it right, you can just hit the show command in order to do that. All right, moving on. So the next task is configuring ACL to protect access to switch 1. Okay, so similar to what we did on router 1, we're going to do on the switch. Okay, so let's create the same access list. So IP access list standard 5. We're going to permit 192.168.10.129, and we want to make sure we log that traffic. And we also want to deny any other IP, and if we're going to deny it, we should log it in order to see who's trying to get into our system that's not supposed to. All right, I'm going to exit out of that, and now we need to go into our line VTY line. So line VTY 0 through 4. Line VTY 0 through 4 means that it's going to allow 0 through 4 terminal lines. So we can have a maximum of 5 terminal lines at once on the switch. Generally, that's what you do, 0 to 4. You can limit it to even less, like line VTY 0, 2, and that would only allow 0, 1, and 2, which is a total of 3 terminal access to the system at one time. But that's what line VTY 0, 4 means. Okay, so we want to make sure we transport input SSH, login local, and we want to use that access class 5in, and voila. That should be enough. What is needed? Okay, using a standard ACL, permit only the Linux management server to access via SSH on switch S1. Make sure to log all denied traffic successful entries, and we did that. So we created the access standard list. We permitted 1 and 2, 168, 10.129, which is that Linux management server, and we're going to log every successful entry and deny entry. So after that permit statement, we have a deny any log. We entered the line VTY access, did access class 5in, which makes the use of that access list that we created. So it's access class and then 5 and then in for traffic that is coming into the line VTY lines. We indicated that the transfer input is going to be SSH. You want to do this because if not, if you don't, then it will allow Telnet and SSH, but we want to only use SSH. We don't want to use Telnet. And then login local to indicate that we are going to permit access through the line VTY terminal access. So login local for that. All right, so after we completed that task, we're now asked to set switch 1 to use router 1's management IP as its Ntp address. So, as I explained earlier, we do not have internet access on our switch. If again, well, I don't need to do the ping command. We don't have access to the internet, so we're gonna get our Ntp time from our router instead. So let's do that by doing Ntp Server, and we're gonna use the server's gateway's address for VLAN 30 since we use VLAN 30 for our traffic to manage anyways. So Ntp server 192.168.10.158, and we also need to set the time zone, and we do that by typing clock time zone ADT and -4 because we're in the summer. If we're in the winter and not using daylight savings, it would be EST negative -5, I believe. Yeah. I always mix them up. Anyways, but it is the current time, 21:58. It's 9:58 on my system. You cannot see it, but trust me, it's 9:58. That is the correct time. Okay. All right. Oh, let's go back to router 1. Remember I had indicated that it may take a little bit in order for router 1 to synchronize. Hopefully it has. So to view that, we do show Ntp status, and the clock is synchronized. Stratum 2. And if we were to go back to switch, let's do the same. Do show Ntp status. Clock is currently synchronized, and as I indicated, it's Stratum 3. Stratum 0 is the actual time. Stratum 1, which would be Google's server that is collecting it. So it's one hop from the actual time source. And then our router is 2 hops from the actual time source. That's why it's Stratum 2. And now our switch is now 3 hops because it's pulling time from our router. And now Stratum numbers is important because you don't want to have a higher stratum, because when it's higher, that means it's further away from the actual time source. So there is set organization. I forget the name of the organization, but they are the time, I guess, arbiters of time for the world, and that's where Google pulls from them, and that's why I like to use Google's IP for its for its time. That's why I like to use Google for timing in the lab environment. I wouldn't use that obviously in the work environment. Your work where you work, they would usually have a policy on which servers to use for timing. So whether you're with the government or government agency, or whether you're with a corporation, policy will determine which is your Ntp servers that you're going to use for timing. But in our lab, we're just going to use Google's for timing, and then for our switch, we're using our router 1 because router 1 collects. There's no need to have multiple collecting from the original time sources. It's easier to just pull timing from our router since it's closer to our router, and we don't need to have so many devices pinging the Google's time clock when we can just do it on one machine on our system, which I'm using router 1 to do, and then our network devices we just pull from our system, which is router 1. Okay, beating a dead horse, I know. Moving along. Okay. Verify NTP. We did that. Verify connectivity to switch 1. Verify the connectivity from Linux Management Workstation to switch 1 using SSH. Okay, let's pull up our Linux server. I'm going to connect here. Test 1, 2, 3. That is the password. Boop, boop, boop. Let it log. Takes a little bit in its first initial log, but it works. Okay. First thing I want to do is I want to make sure that I have a proper IP address, which I do because I pinged it earlier. That's good, and I want to make sure that I can that I do. This doesn't have internet, right? Okay, let me make sure though that I can ping the gateway. So 151.158. That is the router 1. Good. We want to do to router to switch 1. We can get to switch 1. Good. And now I'm going to use SSH. So SSH in a Linux machine, you do SSH, then the user. So in this case, it is admin that we created, and then we'll put at and the IP address of our switch, which is 157. Oh, okay. I need to use an encryption cipher. So I'm going to use -C to set the cipher, and then AES128-CBC. Yes. Okay, now it's asking me for the password, and if I recall, it is that strong password that we created. Voila, I'm in the switch, and enable password, which is Cisco, and voila, I'm in the switch. Do show when I don't need to just do show run. Show run in order to view the configs. All right, good, and that works. Let me do another thing. I want to make sure that ACL is blocking. So I'm going to pull up a second device. In order to verify that SSH is being blocked and only allowing that server. So this is Linux user 1. Its IP address is 192.168.10.1, which is our user VLAN. Make sure that I have the correct IP address. I want to make sure that I can ping. So ping 192.168.10.157, and I can get to the switch via ping, but I shouldn't be allowed to SSH. So SSH admin 192.168.10.157. Connection to host, connection refused. And that's the message we do want to see. I'm going to lower this down, bring back switch 1, and right here, June 23rd, which is tomorrow. All right, because the time that's using, looks like it's using GMT. That's weird. Anyways, looks like the clock isn't working after we set up the NTP. But anyways, we have a denied packet here. Access list 5, 192.168.10.1 was denied, which is that user's IP. It was denied. So our access list is working. All right. All right, going back to the task. Now we want to install, I'm going to close this guy, we don't need you anymore. Install on our server, so let me get out of the switch. Install Tftp. I'm going to use this command, sudo apt install tftp d-hpa. I think I may have already installed it, but this would be the command that you would use to do it. Is already in snooze version. Okay, let me make sure though that it's really using this sudo apt update. I already installed that application because I previously tested it out. I forgot. I got to do this first before anything. And I even wrote it here. For the following portion of the lab, we will need to provide internet access to Linux management workstation. In order to do this, in the previous lab, we did not allow VLAN 30 access to the internet. So now we need to permit internet access in order to install the needed applications and updates. In order to do so, we will need to make a couple of changes on the router to permit the traffic. So if we go back to router 1, and I do show access list. Okay, so this standard access list is the access list that we use to only allow our line v2i connection, so SSH. And then standard access list 10 is what we use to permit gee, it escapes me, not Ntp. Right, okay, so our standard access list IP access list 10, this is what we use for our natting. Okay, so we created a rule to permit the user traffic, and we also created a rule for our server traffic access to the internet. Now we need to create a rule that would permit the other network. So since we're using 10 and 20, I want it to be in certain order, so that should be easy. So we're going to go configure terminal, then IP access list. This is a standard access list, so type standard and then 10, and that will provide us access. Now, since I don't want to have to rewrite the whole access list, I'm just going to type 15. 15 is in the middle of 10 and 20, so it will be written in between those. So we're going to permit 192.168.10.128, and we use the wildcard mask to determine the size of that subnet. So it's 0.0.0.31 because this is a 224 subnet mask, and the wildcard mask is the opposite of that subnet mask. All right, so we've now permitted that. We need to, in order to allow the natting to occur, so there's when you do natting, you identify the source for natting. Man, so do show off. I can't. Yeah. So IPNet outside is 01, but we need to change the IPNet inside source. And we remember this was our original router on a stick lab. We have different VLANs and which are set. So as an example, do show run interface Ethernet 0/0 dot was it 24 say users VLAN off the top of my head. Yeah, VLAN 24. They have IPNet inside that permits them that permits that VLAN access. So we already are allowing through the access list, but we need to make sure we add the IPNet inside on our sub interface of VLAN 30 that will allow us our internet traffic. So we do that by doing getting to the sub interface, and we do that by doing 0/0.30, which is for VLAN 30, and we're going to type IPNet inside. All right, and now I should be able to access the internet. Let me close that. I want to make sure I can. So ping 8.8. Good. And I do believe I use the DNS server. So let me verify www.google.com. Yes. Okay, so DNS is already configured. We don't need to set DNS on this server. But if you didn't, you can just go through here, wired settings. There, it just took a bit. Click on the icon. It's a cogwheel icon. And you'll see here DNS is already there, but if you need to configure it, you click on the IPv4 tab and make sure you add the DNS. And I use 8.8.8.8 in our lab. There are different ones you can use, like 1.1.1.1. It's also a very popular one that's used nowadays for DNS. The other Google DNS server, I believe, is 8.8.4.4, which is another one that you can use. All right. Or policy will dictate which is your DNS server on your network. If you're in a working environment, obviously. Okay, so we can ping. Now we can do app sudo app install, and well, I want to make sure I can update. So sudo app update. I want to get the latest packages. I'm gonna have to edit this because it's taking a little bit. Okay, I see that I have 545 packages to upgrade. I'm not gonna run the apt upgrade. Just gonna do the apt installs, but Tftp was already installed, so we don't need to do that. But we did need to make sure we have internet access. So let's go back to now configuring our Tftp server. So after we do the sudo app install Tftp, install that HPA service, we can verify by doing sudo system ctl status tftpd-hpa, and that's going to be the service, and it is actively running. Okay, so TFTP is currently running. Okay, verify that the TFTP service is active. Great. All right. First task we need to do to make sure our TFTP is working properly is edit the TFTP HPA configuration file. Now, I may have already done this as well. Well, I did, but I forgot to delete some of the files, or maybe I did delete some of them. But anyway, so sudo nano etc default tftp. Oh, gotta type default correctly. Default tftpd-hpa. The username, that is correct. This is probably going to be different. So that was one of the changes I made sure to add, which is make sure to create a directory from the root and call it TFTP. That was just my preference. You can use it from wherever you want, whether it's a local user, which I wouldn't necessarily do, If it's in a corporate environment, because a local user could, in the future, you could move on to another job, and then if you're the only one that uses that, the next network engineer is going to have to completely, after they wipe your system files, is going to have to completely redo everything. Make sure he's pointing to a Tftp server that's accessible from everyone. So I did that by creating this /tftp from the root server, and we'll create that directory if it's not already created. The other thing that we need to change is in TFTP options, you'll see it as only quite possibly --secure. You need to add a space and then do --create. Everything else is going to be the same. So the username that's going to be used is TFTP, and the TFTP address is obviously port 69, which is the UDP protocol number 69 for TFTP. And this colon just indicates that every IP on this server on port 69 will be able to access that. All right. So if you don't have those changes, make sure you add, and I list it here on my website. We will need to add the --create in TFTP options, because that gives us the ability to add new files. Without the --create option, you won't be able to create or upload new files to the TFTP server. Meaning, without that option added on the config, when you try to upload a file that doesn't exist, which primarily that's what you do, for backing up, you'll save your running config and you do copy running to the TFTP server. If you don't have the --create option, the TFTP server is not going to allow it. So that needs to be done, and you can follow that direction on my website. Again, in the description, I'll have the link to that page. Okay, now make the new TFTP directory. I may have already done that, but let me just change directory to our root directory and do ls to see what files I have. TFTP is a directory and it is created. So let's do change directory to TFTP and do an ls to see what I have there. I am going to delete that. So I'm going to remove r1 config, and I need to use sudo. So sudo remove r1-config. And now that file does not exist, let's move out of there. Back to our root. Okay, permit the TFTP service to write to the directory. Okay. I don't have to do this because I already did. And I should have reversed it, but I forgot to do that in preparation for this lab. But as I state here, first you're going to create the directory, and then after that you want to assign TFTP as the user and the group that would be the ownership of that directory. The reason why is because if you don't, obviously only root will have it, because in order to create that directory you have to use sudo. So if you don't, the ownership will be root, and when you try to do copy run from your router or your switch, it's not going to work, because obviously when you're doing it, the service that is using it is your TFTP server. So I don't believe there's a way, or maybe there is a way, to use a specific user when you do TFTP. I know you can with secure copy use, which is another way of copying files, but with TFTP, I don't believe you use a user. You might. Anyways, we have to change the ownership of that file. So in Linux, if you let me bring it up here, show it here. If I do type LL, I'm in the root directory. You can see the owner of the lib directory is root, because obviously root is the appropriate owner. TFTP, though, I have it already changed. But let's change it. So I'm going to do change owner root, comma root. I mean, not comma, colon root. Because I want it to be root root. And then for the directory TFTP. Now, if I were to do a long list command LL, you'll see that the directory belongs to root. And that's how it's probably going to appear after you created your file. So we need to make sure TFTP is again the user, which is the TFTP service user. That is the owner of that file, in order to, when we use the copy run config from our switch and our router, it appropriately will save that file. If not, because TFTP is of less than root access, and we don't have TFTP added to the wheel group, which I believe the wheel group is the sudo access group, it won't be allowed in. So again, that's why we're doing it. So we're going to do change ownership TFTP, which is the user, and then the group is TFTP as well. And we're doing for that directory slash TFTP, and I got to use the sudo command because it will require root privileges in order to do so. All right, again, verify. This is what you need to verify, that when you do type LL, your TFTP directory, TFTP is the user and TFTP is the group permitted to save to that directory. Great. Okay. We need to restart our server in order to make changes, to make those changes that we made on the config file. If you did add that -- create, you need to do this in order for those changes to be saved to the configuration and booted up with the appropriate configurations that we do to allow TFTP, right? So you do that by typing sudo systemctl restart to restart the service, and the service is tftpd-hpa, and that's going to restart that service. All right, so now we go back to our router 1. Okay, Cisco. Okay, and now I want to test that I can copy the TFTP file. So remember earlier I had deleted the contents in that directory. I'm just going to go back to that directory to indicate and show you that it is empty, right? And do copy run, not copy run start, copy run TFTP. The IP address that we use is 192.168.129, which is the Linux server's IP. The destination file name is r1config. Yep. And the file was copied, and we can verify by doing an ls, and there it is, r1config. And if I were to cat that file to show you the contents of that file, you can see that it is the actual configuration. And I'll do real quick on switch 1 to verify the same, that it can copy 2 by doing copy run TFTP. Add the IP address of that Linux server, switch 1 config. Boom, it has copied, and if you go back to the server, and do a ls to view the contents of that directory, and now we see switch 1 config file is also there. If I do a cat switch 1 config, you can see that it is the config file of switch. All right, so now we completed that. The next task at hand is installing Snmp, because we want to be able to access Snmp from our Linux device. Ooh, man, I'm gonna have to edit the crap out of that video. It's already at an hour long. Anyways, now we're gonna do install Snmp on our Linux servers. We do that by doing sudo app install not Tftp, Snmp. Is it Snmp? Just Snmp. Yep. Snmp. I may have also as well installed it. You'll probably get a longer message of the installation. Just type Y. You might have to type Y to install after you do that command, and then it will install the Snmp application. All right, so we have Snmp installed, and we can test the Snmp configuration. I believe I did that with router 1. So let's do Snmp walk. So Snmp walk version 3, because we're using Snmp v3. The user is Snmp admin, and then the authentication is auth priv, or the level security is auth priv for authentication, and privacy encryption. So -A to indicate which protocol we use for authentication, which we indicated SHA-1. So SHA, and then we type the authentication password, which was capital C, capital I, lowercase SCO, #12344, and after that we need to do for the privacy encryption -X, and we indicate that is AES, and the capital X to indicate the encryption password, which is CI in lowercase, and then capital SCO. I believe is 1234 pound. I have it written here. Yeah. And we need to indicate the IP address. So the IP address of that router is 192.168.10.158, which is the gateway for VLAN 30. And voila, Snp v3 is working. I'm not going to allow it to go through because it's going to provide you all the information. But if you see here with Snp walk, if we were to do an Snp get and use this information, which is ISO.3. This is the OID. Yeah, the OID. If we were to use Snp get and we use this OID number, which is ISO.3.6.1.2, we will get back this information, this string, right? Is this type string, and this is the string we will get back, and so on and so forth. This appears to be the string command, the OID, in order to get the name of the network device. So it goes network device dot domain. So we use mylab.local for our domain. So r1.mylab.local. And that is the official name of our device, right? And so on and so forth. I'm not going to do the Snp walk completely because it's going to provide you lots of information of your router. And you use these specific OIDs for get commands in order to get the status of the router. In this case, router or Cisco device. You use those specific OIDs in order to get this specific value back to you, right? If you go online and you search MIB for Cisco router, router version that you're using, or the switch, and you'll find all the OID, common OIDs used, and then you can use Snp get and get the information status that is defined by Cisco, and they will give you back the certain data. So we use this in as an administrator because you want to be able to get quickly the access information without having to log on. Obviously we would use normally a network management system like SolarWinds or Nagios or any other application that does network management system. You would use that system in order to get that information for the most part. But installing Snp on your server and being able to do a Snp walk, you're able to collect that information. And that could be used, obviously, if you use Python, for example, to get information on certain things. So let's say you wanted to get information on an interface, on the amount of data that is being processed through that interface, you can use Snp in order to collect that information and not have to actually log onto the router to get that information. You can just have a Python script, for example, run periodically to get that information and then update that to a logging server of some type or what have you, so that you can determine the traffic of interface. And you can do a whole bunch of stuff with Snp. Anyways, I digress. Let's going off. We're talking too much about that. So we tested Snp. Now we want to do is install rslog or syslog for our syslog. So I have it here. Sudo. Let's go. Let's start this. Let's clear this mess. I'm gonna show it down here. Do sudo apt install rsyslog. Already the newest version. So I already have it installed as well. Verify the rsyslog service is running by using the sudo system status. So sudo system ctl status rsyslog, and it is actively running. Okay, so that system is up and running. Configure syslog to run in server mode. Edit the config file using Nano. Do this by entering the following command: sudo nano etc root, then etc rsyslog.conf. Okay, so this is the configuration file for rsyslog, and we want to uncomment load imudp and load imtcp, because we want to allow UDP and TCP on syslog. Okay, And by uncommenting and you seeing it without the pound sign, it is uncommented. So that is a configuration that is now available. Okay, the next part is create incoming logs template. Okay, create a new template receiving remote messages and add it just before the global directives and enter the following lines. The following lines are there. So I'm gonna before the global directives, and we're gonna type $mod load with a capital L IMUDP $UDP server run 514, and that's basically going to expect UDP on port 514, which is the default UDP protocol for Syslog. And we're going to type local 7 period asterisk var log Cisco. So all our Cisco syslog are going to end up in that directory. And then $allowed sender UDP UDP comma, and we're going to do 127.0.0.1, which is the local local IP, and we want to allow 192.168.10.158, which is our router's IP. All right. Okay, good. I'm going to exit out, save those changes to the syslog file. Okay. Now let's move to the appropriate directory, which we said was going to be let's move, so change directory var from the root directory var and then log. Okay, make sure I'm here. Did I already added Cisco? I didn't. I believe I didn't. Using the following command, sudo touch Cisco while in the varlog directory, create the file so that it may receive the data. Okay, so we're just going to do sudo touch Cisco, and that is going to create the Cisco file that will receive the logs. And I want to make sure recheck. So sudo nano etc versus log conf. I want to make sure that I didn't put a I didn't put a slash. I want to make sure I didn't put a slash, because if I did, then it's going to be looking for a directory and not a file. So Cisco is the file. Okay, good. I just want to make sure I had that correct. We created a Cisco file. Why did we create it? We created it because it needs to be created in order to save the information to that file. So syslog, we told the syslog configuration that the information that you receive from 10.158, which is our router, we wanted to save that syslog data to that file. So probably in a working environment where you have multiple network devices, you might not necessarily want to just create one file. You may want to create a directory of Cisco and then a file for each device that you're sending the data to. But we don't have to do that here because it's just a lab environment. So now send the syslog data to the Linux management workstation. Add the source interface. Make sure to log the user info. Set the login severity level to receive information level 6. Add the hostname as the origin ID so that the data the syslog sent will display the hostname of the router. Okay. And that should be pretty simple. We just got to go on our router. Wait, we did make some changes on the config file. So anytime you do config changes, you need to restart the service. So let's do sudo systemctl restart our syslog. Okay. And I want to verify that the system is up and running after I made those changes, in case if I made a boo-boo and a change created an issue, which I don't believe we did. Okay, it is active and running. Extras config. Well, there was an issue apparently. Extra characters config. What does it say there? Module Ntp already config. Maybe I didn't need to uncomment that because it was already. Anyways. Yeah. Okay. Now that we made the config changes, we've restarted the service and we verified that the service is currently running. Let's go back to our router. So we'll go back to router R1 and let's do the configuration for our syslog. So got to get into privileged exec mode and then global configs by typing configure terminal. And we want logging host 192.168.10.129. This is going to indicate, hey, your syslog sent it to this host IP, which is our Linux management device, right? We're going to set the logging source interface. I want the source interface to be specifically VLAN 30 because that's our management. So to do that, I'll have to type source interface Ethernet 0/0.30, which is the sub interface for that VLAN management VLAN. Okay. I want to log our logging user info. Also want to do logging trap 6. So why 6? Syslog uses security levels or service levels, I believe is what it's called. And we want the severity levels is what it is. And we want informational. So that means everything that is informational. So it goes 1 through 7, right? Or of higher severity, and higher severity is higher by the number being lowest. So as you can see, emergencies is severity of 0. We definitely want to get those syslog messages. So we want everything that is informational or below. And below meaning the higher of the severity level. Okay, so logging trap 6, and we want the origin ID. So logging origin ID to be our host name, right? And after we do those changes, let's do logging on, and that should start the syslog messaging sent to our syslog server. Let's make some changes on our system in order to make some syslog messages. As you can see, it is already sending traffic to that host, but let's do some new. So show IP interface brief. Let's say well, let me just for because we're in a lab environment, I'm just going to shut interface Ethernet 0. No, not interface 0. Interface Ethernet 01, which is our outbound interface. I'm going to shut it and then no shut it to bring it back. So that should create some syslog messages. And then let's, yeah, as you can see, it lost neighborship. So there's a few messages that have occurred. Boom. Now, remember I mentioned severity level. If you want to know the severity level of the message, if you see here, the number that's in the middle of the message. So here, link 3. The severity level is a 3. Meanwhile, this message, the severity level is a 6. I don't remember off the top of my head. This is one of those things I do need to learn for Cisco CCNP Encore. Heck, if you're CCNA, you should also try to learn this information. But if you do, well, yeah, when I was doing the command earlier, so login trap question. Yeah. Oh, because I'm in the interface. I'm in the. Okay. Go back to. Yeah. So, severity level 3 is an error message, right? Meanwhile, severity level 6 was just informational. So, this message here is an error message. Error message because, Ethernet 01 shouldn't be shut. Meanwhile, here, this is a severity level 5, and severity level 5 is a notification. It's notifying, hey, we lost neighborship, right, of our tunnel interface, which our tunnel interface in the last lab was used to set up our Jerry tunnel in order to connect both our sites, right? So that's how you read the syslog messages. So the syslog messages are currently being shared on the console, and that's why we're seeing it. And hopefully, if I did everything correctly, we should see those messages that I created on our syslog. And if we go back here, so that Cisco, if I do a cat on that Cisco file, didn't I create Cisco? Oh, I know what I did wrong. And I have it here. We have to change the ownership. And again, because I created that file using that sudo command, if we do a long list of the files in that folder that I'm currently in. Here, Cisco. What do we see? Root. So this is a perfect example why we need to allow the service to do it. So in order to do that, we got to change the ownership, and I have it here. I even listed it here because I should have read. Change ownership of that file. So we do that by doing sudo change own or chown syslog :syslog, and that is user syslog, group syslog, and then the Cisco file that because we want to change the ownership of that file. So now if I do long list, let me just do a grep command grep Cisco because I don't want to show all the contents of that anymore. Syslog is now the owner of that, and Syslog can read and write because the owner can read and write. The group can just read, but the owner can read and write, right? So now if I go back to router R1, which is good, so this is good, to show that. Then let's do the same thing again. Let's do configure terminal, and I'm going to interface Ethernet. Again, I wouldn't do this in a live environment. This is a lab environment, so I can make these type of changes and cause outages and not be a big deal. But you wouldn't obviously do this in a live environment to test your syslog. You would just be patient and wait to see syslog messages accumulate and be sent over. You wouldn't want to shut down a main interface like I'm doing. I'm doing this because it's a lab environment. We want to see it, right? So interface Ethernet, and let's shut down again that port. Let's give it a little bit of time. Let's have the router create some syslog messages. So boom, 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 boom. I'm going to do no shutdown because I wanted that system to be back online. Do no shutdown. Get the system back online. And again, it's creating more of those syslog messages. So each one of these are syslog messages because we're consoling on the router. We're seeing these syslog messages. So we have adjacency again. So show IP EIGRP neighbors. Okay, I'm back up on the neighborship, and then we do show IP route. Back up. And if I do a ping 8.8.8.8, okay, we got internet access, so the system is back up and running. Okay. We go back to our Linux device, our Linux server. Now, if I do a cat on that file, voila. Now we do have syslog messages being accumulated. Let's see, I was trying to expand it. Obviously, I'm in a smaller window, so I can only expand a little bit. But these are the messages. 2021, 06 June 22nd at 21:54. This occurred, and I can tell you the time is off by 1 hour. Time is off by 1 hour. But anyways, yeah, because it looks like it did. It might be the time on the local server that needs to be adjusted. Yeah. Oh, yeah. Yeah. So, okay. So the local server time is 21:56. Obviously, that's not the correct time. I need to change the NTP for my server, and I can do that. Obviously, I would use the router, or even maybe the switch. No, I would use the router as the NTP source for my network. But neither here or there. You do see that syslog is being generated and syslog is being captured, and again we have that information now being sent to our Linux server. So we've done quite a few things in this lab. We created a banner, to deter unauthorized access. We did Snmp. Using Snp v3, created a group first, and then the user. And those are primarily what you need in order to establish Snp v3 on a router. We set up an ACL to block all SSH traffic except for SSH traffic from our Linux server. We set up syslog. We did copy run Tftp to our Tftp server, which is our Linux server. So there's quite a few things that we did managing wise of our router and our switch. And those are, again, technologies, common technologies that you would use in a day-to-day environment as a network administrator. And that's why it's important, and that's why this lab is a good lab. And again, in the description down below, I have the link to my blog post where I go step by step, of how to do this lab. If you prefer to see it on the web, and you can go. The way I have it set up on my website is I explain the task that you need to complete. Specifically for Cisco, I explain the task that you need to complete, and I also hide that task. So if you're using it as a way to study, you don't necessarily want to see how it's done to test your capacity on the knowledge of that lab. So we use it to hide that information and then show it when you want to see it. So I did that on purpose because I use it. I want it to be as a tool for someone who's doing, lab work. They don't, I've seen on other websites where they share labs where they provide you, the steps how to, and you're like, or at least I'm trying not to see it, because I'm trying to verify that I remember the topics and I know how to do it, right? So that's why I have it hidden, and once you hit show, then you'll see the proper configuration, right? So we did, like I said, we did a few things, and we used our Linux server as well in order to verify the connectivity, in order to verify the technology, using Snp, syslog, and what have you. So hopefully you learned how to do those things on a Linux device and whatnot. And key things to remember that, for Tftp and for syslog, if you run the command to create the file using sudo, which is the proper way of doing it, because you ran the command sudo, the ownership of that file is root. So in order to allow the application to properly write to that file, whether it's syslog or Tftp, we need to change ownership to those pertinent applications. So for Tftp, we did a Tftp change ownership Tftp as the user and the group, and same we did for syslog. And if you don't, you saw it earlier that it wasn't saving the syslog. And I'm going to keep that because even, making mistakes is good. That's how you learn, right? Then I was quickly able to, see the error in my ways and change it. And that's good because, don't be afraid to make mistakes. That's what, especially in a lab environment, that's what we're here for. Make mistakes and learn from them, right? Better to do it in a lab environment than in a real scenario. But for troubleshooting purposes, it's good that you make mistakes and you learn from them, because that's the only way you're going to really learn. Okay. So I hope you learned quite a bit in this lab. I know there's a lot of applications, a lot of technologies, like as I said, and features that Cisco provides, and there are many more. These are not the only ones that you would use in your day-to-day, network admin work. Like for example, Tftp is not necessarily the preferred method nowadays. We use secure copy, which would require doing it via SSH, and there are other things that we can use as well, technologies that we use to manage our devices. All right. So anyways, I think we've covered enough. I got enough to edit this video anyway, so make sure you hit that like button, subscribe to my channel to see more videos like these in the future, and comment down below what you liked, what you didn't like, any suggestions of labs that you'd like to see in the future as well. Make sure you can comment that down below. But until next time, bye.